Hello, this is John from caveofprogramming.com. In this tutorial, we're going to take a look at the standard bind function in C++ 11. So since the last tutorial, which was a long time ago, I've moved to Berlin and I've got a new computer. I'm in a new room, obviously, and I've got a German keyboard, so things are going to look and sound a little different. Hopefully the echo isn't too severe in here. I'm not sure what I can do about it. But anyway, let's take a look at bind. So bind is one of those things that I haven't really used this a lot. It existed before, but previously you had to use like a Boost library. Boost is this massive collection of free C++ libraries you can use. And you had to use something from Boost to do this, as far as I know. But now bind is supported natively in C++ 11. And bind allows you to create kind of aliases to functions, a bit like function pointers. But there are some other things that you can do with them, basically. So it's worth knowing about. It might not be something that you use a lot, or then again you might really get into it and start using it all the time. But it's at least worth knowing what it is and how it works. So we'll go over just the basics in this tutorial. So here I've defined a function called add, and this is just a kind of random test function. I've given it 3 arbitrary arguments. So these happen to be just integers, a, b, and c, and it's just returning the result of adding those 3 things together. And I'm also outputting these arguments so that we can see what they are. So we can run that quite easily. Let's add up 1, 2, and 3, hopefully to get 6. And I'll put a cout in here. Let's put in cout, and my typing is going to be a little bit slower than usual because I just got used to using a Hungarian keyboard, and now I'm getting used to a German one. Okay, so let's run this, check that it works. Should be no problems there. So there we are, we get 6, and these are the parameters being displayed. I've included the functional interface here, and we need to include that to use bind, the functional header. When I tried this on another computer a couple of days ago, it actually worked without functional. I'm not sure why, but you should include that anyway, you're supposed to. And I've got using namespace standard. We need that as well because this bind function is in the standard namespace. Either you have to do using namespace standard, or you have to type it like this, standard bind, one of the two. And I'm also using namespace placeholders because we're going to use something called placeholders, again from this functional header in this tutorial. So I can create an auto type like this, and let's give it a name, something other than add, because that would conflict with add in the existing scope. Let's call it, I don't know, calculate or something like this. And I'm going to set that equal to bind, and we're going to supply some parameters to bind. So the first parameter that I'm going to supply is going to be a function pointer. So I can just type the name of the function. I think it used to be the case in early versions of C++, or certainly some years ago, that you used to have to specify a function pointer with an ampersand like this. I think I've mentioned this before, but now we don't. We can just specify like that, but you can add the ampersand in if you like. So we've got a pointer to the function, and then we can put arguments in. So let's put in something like, I don't know, 3, 4, and 5, which should sum to 12. As soon as I put myself on the spot, I can't even tell you my own name almost. Okay, so now we can call this via this sort of bound alias, a sort of bound variable that's bound to the function by saying let's call it calculate, a little bit shorter. Calculate, and we can pass in, we've already passed in all the arguments that we have to here. So every time we call it now, it's going to be called with those arguments, which is one interesting thing that you can do with bind. So we can just call calculate, and of course this is going to behave, it's going to behave like this function, but whenever we call it, it's going to be supplied with these arguments. So let's do cout on calculate now. Just a normal cout with a endler there. Excuse me. So I'll run this, and now we see that we're adding up 3, 4 and 5 to get 12, and here are the arguments that are being supplied. So we've created just a really simple alias here. Now you can, if you want, just supply the arguments as normal. Maybe that's a bit useless, because all we would have done then if we supplied arguments here would be to give this function a different name, but we can do that, and we do that using placeholders. So as long as you've got include functional and using namespace placeholders, here instead of actual parameters you can put _1, _2, _3, however many of these underscore things you have you need for arguments to your function, like this. So now this means that we can actually supply arguments for calculate here. So let's put in something that I can add up quickly. Let's put in 10, 20 and 30, which should be 60. So if we run this, and someone also pointed out to me recently, I don't know how I've managed not to notice this, but there is actually a build button in Eclipse on the toolbar here. It's like a little hammer sign. So I'll click that to build it quicker than using the menu option. And it's nice, I find, just to build a program sometimes to check if there's any errors in it before we then try to run it. Because if you run it and there are errors, then you have to get rid of the dialog that says, are you sure you want to run this? Let's run that now. So we've got 60. You can combine placeholders and actual arguments. So one thing about these placeholders is you might wonder, why are they numbered? Why aren't they, something? Why can't we just specify the number of arguments here to pass with a simple 3? Because there are 3 arguments. But the thing about these placeholders is that you can change the order of them. So we could say, okay, this, whatever's in this position here is going to be supplied as the first argument to the function. So these numbers 1, 2, 3, they represent the order that we supply them in here. So that's 1, 2 and 3. But we can supply them to the actual bound function in a different order. So we could, for example, supply let's supply 2, then 3 and then 1. So that means that these will be passed in a different order. So the first argument here will actually be the second argument that we pass in, so it'll be 20. And the second argument here that we're passing to this function is passed via placeholder 3, so it'll be this one, the third argument that we supply. And similarly, the third argument to add will be the first parameter that's supplied here when we use this bound version of it. So now we expect to get what? So we've got 2, 3, 1, so that's 20, 30 and 10. So that's what we expect to see down here supplied to add when we run the function. Let's try that. And if I've managed to lose you there, then hopefully you'll see when you try this for yourself how this works. So let's run it. And we get 20, 30, 10. So the first argument is the second placeholder 2. Okay, so we can mix and match. So we could say, okay, let's suppose I want let's say I want the second argument here to this function always to be 100. So I could put 100 in there. And then we're only going to supply 2 arguments when we actually call the function. So let's supply 10 and 20. So those are going to be represented by placeholder 1, which is 10. Placeholder 2 is 20. And we're supplying 20 first, and then 100, and then 10. And if this does sound complicated, then I'm making it sound more complicated than it actually is, because it's not that bad. So now we've got 20, 100, and 10. So there's a whole range of possibilities here. You can use all placeholders or all hard-coded arguments here every time the function's called, or you can mix them, and you can rearrange them in different orders as well. The standard function function or whatever it is, I'm not actually sure now I think of it, but that works with this as well. So what I mean is, let's suppose we have a function here. Let's call it void run, and let's suppose that run expects to take as its argument a function. So we'll use this nice function thing that we've used previously. So let's put in the brackets there. So it's like a template class, I guess it is, or a struct. I'm not quite sure. And in here we specified that we're going to supply here a function that returns an int, and it's going to have two arguments, which are going to be int and int. So this fulfills that criteria. So after we bound it, we've now got effectively a function here that takes two arguments and returns an int, because the original add function returns an int. So that means that this function will accept that. Let's type in here some name like func, and we can just run that func 7 and 3, which should sum to 10, but we've also got the hard-coded 100, so that's going to be 110. And let's actually call that here. Let's say run, and we just call run and pass in the thing we want it to run, calculate, which is our alias, our bound alias to this function here, and we run that, and we see that it gets called with the arguments 3, 100 and 7. I'm not actually displaying the return value here, but of course we can. Let's just put in cout again, like this, and we can check that it works just as before. So we run this, and we get the result 100 and whoops, I did something terrible there. One thing about C++ I hate is the amount of errors that it can produce. So yeah, we've got to obviously change that to an int and return. And let's run that and build it, and it's good. So now we get 110. You can bind to methods as well. Let's just take a look at that before we finish. So this is going to be a common thing to do. If you're going to use bind at all, you're quite likely to want to bind to a method. Let's call this class test, maybe, and put in some brackets there. Closing bracket here, if I can find it on this keyboard. Just format that code. So I'll have like a public section here. Now the difference here is firstly we have to supply a pointer to the method. So we have to type test.add, and now the ampersand is obligatory. We've got to put that in, at least with this compiler. And the second argument here, we actually need to make an object of this class to bind to. And I mustn't forget the semicolon after the closing class bracket there. So we actually need an object, because this method could use instance variables of the class. And those are going to be different for every object. So we need to tell bind which object we're actually binding to. Let's create a test. I'll use lowercase test for the name, and we supply that for the second argument, and then we just have the arguments and placeholders as normal. So if I run that now, we've got a error there. What did I do wrong? Unexpected colon. Whoops. Yeah, I need 2 colons, of course. So now that should work, and if I run it now, we get the same result as before. So now we've bound to a method, which is really nice actually. When I started programming C++, I was obsessed with making the main function a method, which you really can't, although I did find some tricks that sort of let me simulate that, but bind would have been handy there, I suppose. I think that's it for this tutorial. The thing that I'd recommend that you do is just practice this, especially if I manage to lose you with my explanation of mixing up arguments and placeholders. Just try to bind to a simple function, maybe without any arguments. Then try supplying hard-coded arguments to bind that will be supplied every time you run the function. Then try the placeholders 1, 1, 2, 3, or however many arguments you want to pass to that function, and try mixing up the placeholders, changing the order and seeing what happens. You might want to put a cout line in your function so you can see what's actually happening there. And of course try the not only auto like here, but also try the standard function thing as well, to check that you can assign a bound function to something that looks like this, whether that's a function parameter or just a local variable of this type. You could also do that. And one last thing to try if you are feeling ambitious is you could try binding to a static method. That's a little bit more complicated than this, but it's not rocket science. So if you Google something like C++11 bind static method, you'll find some links, a lot of stuff from Stack Overflow and other places that will just show you example code. And it's worth having a look at that and maybe even trying it out if you feel like it. Okay, so that's it for this tutorial. Hopefully now I'm going to get into the swing of creating some more tutorials for this course. So there should be more soon. And until next time, happy coding.